Okay, let's go ahead and get started. I'm trying having the mic at a slightly higher volume, see if that works better. Anyway, we'll see. So welcome to the second lecture of 143. The question of the day that I did last time was to ask you about your 142 experience. So as expected, most of you took it last quarter, but a fair number of you took it in a prior quarter, so we're not going to want to assume that you took it last quarter. And then lots of people with other experiences, all of which are fine, including skipping 142 if you think you're ready to take the course. So that's we let students make that choice for yourself. So that's up to you if you want to decide to do that. I mentioned that on the calendar, I'm going to be posting resources at the end of every lecture. So there was a link to the video. These were the questions that were asked during the Q&A. Let me say a little bit about the Q&A. It was great last time. There were lots of questions, and I was really glad to have people asking them and being able to answer them. I kind of felt like a lot of them were fairly individual questions to that particular person. So in terms of a resource, I don't think it's going to be helpful for you to read every other question that anybody asked. I mean, it's up to you. You can decide. I mean, I will post it so it's available in case you think that that's helpful to you. But my sense is that what was helpful about that was more individuals getting to ask their question and getting it answered in a fairly timely manner. And I think that's a great resource. I hope you guys continue to do that. Those were all great questions that people asked during the lecture. It's perfectly okay to be confused about something, to need a little bit of extra explanation or something. And I am making myself available for the 2 different time slots that we're scheduled for the lecture. So I encourage you to make use of that resource. I think it's a great option. I posted my first set of lecture notes, and as I mentioned last time, you'll see that I go in great detail. First we did this, then we did this, then we changed it to this. So I think you'll find that my notes are a pretty good resource if there was something you wanted to review after the lecture, that's something that will be helpful to you. My co-author and I, Marty Stepp, and I made the various short videos that will link as they become relevant. Those might be interesting to you. Kind of an extra example of various things. The programming examples we went over last time, and as I mentioned at the beginning last time, I kind of have a great big slide deck of lots of material from 142. That's something that you could use as a review if any of you haven't done 142 here, or if you are a little rusty with 142, you could kind of take a look through those slides to see what's there. So as I said, every day after the lecture, I'm going to post various materials, that are the relevant materials. I posted the first homework assignment. So under the homework tab, you can see now that there's information here about the first homework assignment with a turn-in link. We use our own special system known as Grade-It. That's what you're submitting to when you do this turn-in. So the assignment write-up is here. If you were here physically, I would be passing it out on paper. I think it's helpful to print the assignment write-ups because I think that it's good to review them, take notes on them, highlight things in the assignment write-up. So anyway, it's up to you, but I think that would be something that could be worth printing. And then various resources that are available for the assignment write-up. So this is due next week. Normally these things will go out on a Friday and you'll have until the following Thursday. We can put it out a little early this time, so why not? And there's this 4-day window that you can turn it in up to 4 days late, and then there's the absolute cutoff. So you've got to be sure to turn it in by that Monday date if you want to have us grade that homework 1. Lots of resources here, including style guides that TAs have written. I wanted to mention a specific resource, which is this general style deductions. Well, let me say a little bit about style in general. Is that, I think that one of the things you'll hear people say about 143 is that we're very picky about style grading. I would say we have high standards. I guess you could kind of describe it in different ways. What I don't believe, that I sometimes hear from people, is that sometimes people think these things are arbitrary or hidden, and I don't think that's true. In terms of arbitrary, you would be surprised if, when we go and talk to people in industry, they will tell us that they like just about everything we have in our style guide, and they do more. They demand very good style from their programmers. And so they're very happy to see us enforcing style guidelines. These are generally agreed on guidelines. It's not always 100% clear. Sometimes there's disagreements, but there's an awful lot that we tend to agree on as programmers. And those are the things we tend to have, as style issues. In terms of hidden, so if you say, here's my solution to homework 1, tell me what I did wrong in terms of style, we will say we don't do that. That's what we would call pre-grading. So we won't comment on it before it's graded. So in that sense, you don't find out until it's graded. But we give you lots of examples in advance. We try to be very clear about what are the general style guidelines that we are following. So we try to tell them all to you when possible. I spent a lot of time in lecture kind of highlighting, this is a style issue you could lose a point for, this is another style issue. So I like to think of style as an opportunity. I mean, think of it. Different people in this class kind of are going to find programming harder or easier, You can't easily make yourself a better programmer. You can't easily kind of increase your programming ability. That tends to come through practice, But you can do better with style. If you're coming to the lecture, watching the lectures, going to section, paying attention to this resource I'm about to show you in a second, if you're paying attention, style is something where you can distinguish yourself. You can be someone who gets the style points because you're paying attention, writing things down when I mention them in lecture, for example, and rereading the assignment write-up. Often there are things in the assignment write-up that you don't catch the first time. I've heard from a lot of students that before they do the final submission of their homework, they'll read through the homework write-up one more time to see if there was something that they missed. So if you're someone who's thorough, you do the things that we ask and so forth, you can get more points relative to other students by getting the style points right. So I would hope you could kind of see it as a resource. This general style deductions is something that I introduced because TAs kind of felt like we needed to be warning students in advance that we were about to take off points for various things. And what I prefer is for us to warn you. So there are a lot of style issues that we're bringing into play in Homework 1. Normally, when we post something on this page, it won't be as long of a list as this. But some of this is kind of, we expect that you've done 142 or its equivalent. So, we have a little extra time with this homework and going into next week. So one of the things you should be doing, I said we're reviewing arrays in classes, which is true. We're also, in a sense, reviewing style issues. So we want to bring everybody in the class up to a certain level of understanding the style issues that we're interested in. So this is something that you should be paying attention to. And if any of these things are unfamiliar to you, maybe you didn't take 142 from us, you don't know what we're talking about when we mention these style issues, well, that's something you can fix. You can ask TAs about this. You can ask your TA. You can ask other TAs during their office hours. What does that mean? There are some hyperlinks here where when there's something in the style guide, that's online style guide that we have, we link to the section of that style guide. So this is something you should be paying attention to. You want to try to, in working on this first homework, you want to bring yourself up to speed so that you are going to be producing programs with good style. Tomorrow in section, the Thursday section tomorrow, we're gonna devote it to style. We're gonna discuss. So I've mentioned that the array int list is a case study. It's a sample program that I'm showing you to kind of explain various ideas to you that are relevant to homework 1, and it's a model for you. That if you want to say, well, what should I be trying to make my homework 1 like? You should be trying to make it like this array int list I'm going to show you. Well, in section tomorrow, they're going to show you a bad array int list, one that has bad style. And we've tried to include like every one of the bad style things that we've seen students doing at this point in the quarter. We've tried to throw into that example. So you'll have an opportunity with your TA and the other students in your section to discuss that about array int list. And there's a key that kind of lists all of these different issues. So that's going to be a great opportunity for you to be studying the style issues. Each week, when a new homework goes out, we will list the things that have become relevant style issues that are brand new as of that week. So again, a lot of them for this first one, because in a way we're reviewing 142 type material in working on this homework one. There is a list here of some Java features that I don't want you to use. Not so much that they're bad Java features, but I want us all to be on a level playing field. I want us to be using the same things. And if you have no idea what these things are, that's great. Then you won't be tempted to use them. So this is more for people who do know some Java. These are things that you should not be using. They're not allowed. Okay, I wanted to mention one more thing, which is that the TAs have signed up for office hours. I am going to post that later today. So that will be, there will be under the Zoom links tab. So you know that I've put my office hour link there. Several people came by yesterday, which is great. I love to see people in office hours. And the section links are there. Later today, I will add links for the TA's office hours. So the office hours begin tomorrow. So they begin Thursday. So, and think about it. We actually have a lot of Thursday office hours because we normally have homeworks due on a Thursday. So tomorrow there's going to be a lot of TAs having office hours, but not a lot of students necessarily looking for them during those office hours because they don't have a homework. You don't have a homework due. So if any of you, there's things that are unfamiliar, you're confused, you're trying to come up to speed on any of these issues, the technical Java issues or the style issues, you've got lonely TAs, putting in office hours. They'd love to see you show up and ask them questions. So we have a strong theme in all of this that we throw tons of resources at you, but it's your responsibility to make use of those resources. So the office hours will be a great resource starting tomorrow. I will post the links on the Zoom links page later today. So you can go to any TA's office hours. I mean, it's nicest when you can go to your own TA's office hours, but a lot of times that's not convenient. So you can go to any of the TA's office hours if you need help with any of these things, with the homework, with the things we're covering in lecture, with the style issues, any of that. You can go to the TA's office hours. Okay, so that was tons of stuff. Let's jump into the programming part of it. So we left off here. We had made an array int list. We had a constructor that we made for it, and we did an add command, that would add things to it. I threw in a toString method that made these printing commands work. In section yesterday, in this, I kind of I kind of assigned various other methods of the array int list class. I wouldn't be surprised if you didn't spend much time on it because a lot of the first section you're getting to know your TA and the other students, and there's a lot of time spent on things like icebreakers and stuff. So if you didn't have time to cover these things in section, that's fine. But let me just kind of point out a few things. So we have a constructor that sets up the array. I did the toString. I said the details of the toString aren't all that interesting. Index of is something that was a section problem for yesterday. So it's a method that you give it a value and it searches through the array. So standard array traversal going up to the size, looking to see if that value is there, in which case it returns that index. If it goes all the way through and doesn't find it, it returns a -1. Notice that we're using here size and not the array's length, because remember, with the array int list, we've got some underlying array. It might be a big array, 100 long, in the way we've written the code right here, but there might be only 8 things that are being used right now. So we use size to keep track of. There's the difference between the capacity, how much space is there in general, versus the current size, how many things are currently being used. We had the add command that we wrote last time that appends at the end of the list. I got some questions in the Q&A where people were kind of saying things like, why do we do this? This seems silly. If you know that this thing has an array inside, why don't you just use an array? Well, it's true, I mean, it's called ArrayList, the built-in one, or ours, ArrayIntList, as a way to let the client know that there's an array inside. But if you think of things like, the appending add was easy to do, but what if you wanted to add in the middle, well, actually, let's think about removing in the middle, because that one's a little simpler. If you want to remove in the middle, you have to shift things over to make, to kind of fill in the gap that you would have otherwise. So remove was another method that was on the section problems for yesterday. So, you'd have to write this code, this shifting code that kind of scooches things down, and you'd have to remember to decrement the size. Now, you could certainly write that code. You could do it yourself. But why bother? I mean, isn't it nice to have an object that will do that for you, that will have the loop for you? I was trying to think of an analogy. I don't know that I have great analogies, but I can imagine that if you weren't very used to traveling, you weren't very used to staying in hotels, you might go to the hotel and you might make up your bed in the morning or clean up the bathroom or whatever, and then the maid arrives and you're kind of like, why is the cleaning service here? I can make my own bed. Well, yeah, but the point is you don't have to. Isn't it convenient sometimes to have some service, that takes care of that for you? So this is a little bit like that the ArrayIntList class has this shifting code, so you don't have to write it. You can just call the remove method. And the add method was also on the section problems for yesterday. It's a little trickier, actually, because the loop, you kind of can't shift upwards in the array because you'll wipe out what's already there. This is described in Chapter 7. There's some shifting examples that are in there if you're interested. But actually, this loop, we run this loop backwards in order to kind of scooch things up, starting at the end rather than starting in the middle. So that was a little bit tricky, kind of getting that code just right. Again, a good reason to have it in a class. So if this is ArrayIntList as of what we ended up with at the end of section. We're going to do several additions today. We're going to add various methods. We're going to talk about various issues related to it. And then that's going to lead to a new version of ArrayIntList, which is the one that I want you to look at as the model for getting ready for homework 1. So I have that. I'm going to show it to you at the end of the lecture that we're going to look at kind of the nice version of ArrayIntList that we have at the end. Okay, I wanted to mention a certain idea. When I first started studying all of this object-oriented programming stuff, I went to, there's a conference known as Uppsala, which is kind of the big object-oriented programming conference. It was an interesting experience. The object-oriented programming community is a little bit weird. They have almost religious devotion to some of the ideas. There's different ideas floating out there about object-oriented programming. A lot in common, but then there's kind of a lot of individuals who have their own ideas about how to do software development, for example. And so you'll find there are various gurus, and they'll even call them gurus, who's your guru? My guru is such and such, so it's kind of interesting. When I first started going there, I remember hearing somebody say a statement that obviously this person thought this was a very meaningful kind of statement. They said, an object encapsulates state and exposes behavior. And almost like repeated as a mantra. This is something that his guru had taught him. An object encapsulates state and exposes behavior. I almost asked him what this means, but I thought that then he would say, who's your guru? How could you possibly not know all of these things? But it's a nice little pithy statement that I mentioned this when I teach 142. Some of you may not have seen it if you didn't take it from me. But anyway, we'll talk about these different things. So what are the ideas here? The state and behavior. So state is kind of, I mentioned Arthur Reel talks about this. He talks about the idea of a radio, for example. What are different states that a radio can be in? It can be on, it can be off, it can be tuned to this station or that station. The volume can be at 8, the volume can be at 6, So those are kind of different states of an object like a radio. For us, the state is going to be, in the case, say, of this ArrayIntList, what's in the list? How many things are in the list? What are the values in the list? And so state information for us is stored in fields, that the element data and the size are keeping track of the state of this object. They're keeping track of the individual values that are in the list and how many of them there are, the size, the kind of the current number that are in use. So that's the state information for this object. And exposing behavior, you basically do that by having methods, by introducing methods. Well, like we have a toString method, we have an index of method, an appending add, an add method that adds at an index, a remove method that removes at an index. Those are all behaviors. Those are all, in Real's analogy of thinking of like a radio, you have an on-off switch. Generally you call methods to change the state. When you call the appending add, it puts something new at the end of that list, which means the array has to be updated and the size has to be updated. So, the methods generally are asking about the state or changing the state, and that's, the terminology we use for that is that we refer to that as the behavior of that particular object. At the end last time, so normally during regular quarter when we do recordings like this, they normally have like a minute or 2 minutes extra at the end, so that if I run over slightly, it's captured on the video. They didn't do that. They cut me off promptly, right at the end of the 50 minutes. So I'm going to have to try to watch that. In general, I try to squeeze little stuff in at the very end. It's generally not going to be a problem because usually I've covered the main things that I wanted to cover, and I'm just throwing in a few extra little points at the end. I did manage, I noticed at the end of the video, I managed to add the keyword private here and the keyword private here. I didn't get to talk about it, but I was able to you were able to see that that was the last thing that I did. That's something that we would refer to as encapsulation. That's how you encapsulate the state of an object, is by making the fields of the object private. So what does that do? That means that if you were over here and you wanted to say something like list1.size is equal to, you want to reach right in and set the size. Now, we did that here. I mean, that was kind of the original thing that we did. And I said that's a bad way to manipulate an object. That would be like if you had a radio sitting here and you opened it up, you kind of opened the case up and you were reaching right in and rearranging the wires or something inside. You don't want to have a client doing that. You want to have them use the dials and the buttons and the controls. The methods is what we want them to do. So we don't want to allow this. So I often ask people what would be something that could cause a problem. People tend to think of things like setting it to a -8, which is certainly a problem. Another problem would be something like setting it to be 1,000, because then when it goes to do the toString method, it's going to try to put together 1,000 different things, and this array only has 100 elements. So it's going to get an array index out of bounds because it's going to think that there's 1,000 things in there when there's only 100. So we don't want to allow this. And by making those fields private, that is so, that a client is not permitted to do that. So if I come over here and I hit compile, I'm going to get an error message here that says size has private access in array int list. That is, it's encapsulated. You're not allowed to reach right in and do something like that, which is good. We want to do that. We want to kind of cut off access. But one of the things that takes a while to get used to with this, encapsulation is one of the most confusing things for novices. And I think part of it is that you don't really see the benefit of it until you write really gigantic programs, million-line programs or whatever. And then encapsulation becomes extremely important. But it's a little less important. It seems less important to you guys. But what I wanted to point out is that before I had the keyword private there, I was able to reach right in and manipulate the fields. That's incredible access. That's full access. And we don't want to do that. But what we're doing here when we put the keywords private is the pendulum is swinging back to the other end where we're giving no access. We're cutting it off entirely. And that's a little too much. I mean, for example, what if you wanted to say something like system.out.println list1 size is equal to list1.size. Why can't I, what if I wanted to know that? What if I wanted to know how many things are in the list? Why can't I ask it for its size? But it's, it's encapsulated. It's kind of cut off. So what we tend to do with encapsulation is we kind of try to find something in the middle. We don't want to give full access. We don't want to give no access. We want to give some access. And we tend to do that by writing what are known as getters and setters. So for example, I'm going to have a public int method called size, where I'm going to return the current value of my size field. So I'm going to let a client ask me what is the size, and I'll answer it by returning access to the size method. But introducing this method does not give the client the ability to change the size. It only gives the client the ability to see what the size is. What we're doing is we're exposing behavior. We're choosing what to make available, what to expose to a client. So private kind of cuts it off, but then we decide what to expose, what to allow. And so we're going to allow not access to a size field, but a size method. And this is something, I'm going to putting a parens here. This is a big difference. Having it without the parens, that's referring to a field. With the parens, it's calling a method. And so we're gonna do it in that way. We're going to allow them to be able to see the size, and then when you run the program, it notices that the list one size is 3. Okay, well, what would be other kinds of things? I normally ask the class, what would be other getters and setters that you want? You could think about ArrayList that at the end of 142, there was a final exam question about ArrayList. And do you remember anything that was very useful? And people will often remember that there was a method called get. So what might you want to access? You might want to know what the individual list elements are. What's at the front of the list? What's the next thing in the list? What's the next thing in the list? So there's a method called get that takes an index that we want to include in our array int list. The array list has such a method. And what we would do then is to return element data of index, that we will let them see what's stored at that spot in the array. There are interesting issues that come up when you write a method like get. So I normally, again, it's sad we don't have the opportunity to have a discussion. Normally this is a great question to get some discussion about. But the question that I'll ask is this dangerous, this get method, kind of making this available? Could it cause a problem? And people are pretty good at pointing out that there are some dangerous values of index that you might provide. You could provide a value of index that would not work right. That would be an illegal index. Well, there's another bit of terminology that's used in object-oriented programming, and programming in general, that we'll talk about the idea of a contract. That there's a contract for this get method. Basically there are certain assumptions that the get method makes. And the contract kind of says, well, if you uphold your end of the bargain, here's what I'll do for my end of the bargain. In chapter 4, I mentioned the idea that there's a notion of preconditions and postconditions. This is a good thing to understand the concept of preconditions and postconditions. You don't have to do commenting in the way that I do with pre and post. I like the pre-post style of doing things, but it's somewhat of a personal choice. So you don't necessarily have to do it in this way, but let me mention the idea. The pre-post condition is a way of expressing the contract. It kind of says that the precondition are things that this method assumes are true. That these better be true. So what needs to be true of that index? Well, for one thing, it better not be a negative number. So index had better be greater than or equal to 0, because otherwise you'd be asking me for a negative, and it would be trying to go to an array index that's negative. So that would be illegal. So you shouldn't give me an index that's negative. So the precondition, the contract is that it better give me something greater than or equal to 0. You also better not give me an index that's too big. Now you might think that an index that's too big is one that's beyond the size of the array, but remember, we're trying to kind of have this illusion where we're keeping track of the size. Even if the array was 100 long, if there are only 8 things that have been added to the list, then they shouldn't be asking for an index higher than 7. Those 8 things are in indexes 0 through 7. So we'd want to say that the index is strictly less than the size as well. So these are things that the get method requires to be true. If you want to call get, then you'd better call it with an index that satisfies this. That's the precondition. The postcondition is a way of saying, well, okay, if you do that, then what I'll do is returns the value at the given index. You know, that's what I'll do if you do your part. I'll return to you the value at the given index. Now, some methods don't have a precondition. Like size doesn't have a precondition. You can always call size. So, but other methods do. So let me mention the style issue. So I've said you don't have to use my commenting style. You can comment however you want. But there is something that I am going to require, that every precondition should be included in your comments. We require that you comment on every precondition. And that's going to be true starting with this homework 1. So you want to be thinking about assumptions that this method makes. And so you have to comment on those preconditions to get full credit. So you can do it in the pre-post way that I do, or just in simple text, you know, but you need to say somehow that this is so. You would have to mention that this is a precondition of the get method. Now, it's good to comment on this when we make you do it. And in a way, you know, you could say, well, it's better than what we had before, but a client can still pass in a bad index. I mean, what I would say is, well, look, you violated the contract. You know, you didn't do what you were supposed to do. So if it blows up, I mean, I give you no guarantees about what it does if you have violated the contract, you know, client, if I'm talking to a client. So, I mean, it's good, you know, that's good to do the commenting, because then you're off the hook in terms of any expectations. But sometimes we like to do more than that. So what I'm going to do is I'm going to throw in an if here. Let me just kind of do a pseudocode. Bad index is what I'm going to say for right now. We'll fill that in with actual code in a second. But if a client gives me a bad index, what is it that I want to do? Well, we have an option. This is something that's described in chapter 4, so it's described early in the book, but we didn't practice it in 142. We will practice it in 143, and starting with this homework 1. You have the option to do something called throwing an exception. So I typed the keyword throw. Notice that it's in purple. It's a Java keyword. It's a command. I want you to throw, and then I'm supposed to put a reference to an exception object here. And the convention in Java is to construct a brand new exception object at the moment that you're throwing it. And there's different kinds of exception objects. In this case, I want to throw an index out of bounds exception. There really is a class of that name, index out of bounds exception. So I've got a little call on new here that is constructing an actual exception object. You may have noticed when you had an exception thrown, if you took 142 or your AP, CS, whatever, that when an exception is thrown, your program stops running and it shows you in reverse order. You are in line 82 of this method. It was called from line 38 of this method, which was called from line 6 of main, you know, something like that. It shows you what we call a backtrace, kind of how you got there. And the way that that's accomplished is that we construct a brand new exception object at the moment that we're throwing it, and so it can figure out that backtrace. It can figure out how it got to this point where there's an exception being thrown. So we're always going to write them in this way, where we use the throw command and we construct a brand new exception. There are different kinds of exceptions. We will be very clear with you exactly which kind of exception we want you to throw. The word throw is a little bit odd. You know, I think maybe the analogy is people are thinking about things like, you know, if you watch a football game, you know, that there are referees who throw a flag, you know, and so what does it mean to throw a flag, you know, and then a whistle blows and people stop playing. If there's a flag down on the play, so, you know, an exception is an error, it shouldn't be happening, stop whatever's going on. That's the idea. So it never gets to this line right here, because this command to throw an exception says stop it from running, exit this method, you know, go back to where you came from. Now, there is, in Java, there's something known as a try-catch, where you can say try executing some lines of code, catch a particular kind of exception with some recovery code. So this is kind of what a try-catch looks like. We don't cover try-catch in 143. I mean, it's useful, but, you know, there's a lot of stuff to cover, and among the various things, this is just not something we care that much about. But there is an option for a client to prevent the program from crashing by catching an exception. So, it's good to know that that exists, but we're not going to make you do that. So for us, when an exception is thrown, it's going to just come all the way out. It's going to stop the program from executing because we aren't going to have a try-catch. So it's going to stop. That's kind of the way we want to handle things. I mean, error recovery is actually not a simple thing. But the fact that, somebody can catch it, and then they need to know the kind of exception. So clients need to know that a method can throw an exception and what kind of exception it can throw. So I'm about to give you another one of these style issues, something that you would lose points for if you don't do it right. If your method is throwing an exception, you have to document that in the comments. So I'm going to say throws index out of bounds exception if not. So I'm documenting the fact that if the precondition is violated, that it throws an index out of bounds exception. So you have to mention that it throws the exception, the condition under which it throws the exception, and the exact kind of exception. You can't just say throws an exception. You have to say the exact kind of exception. So that's all part of the grading, starting with homework 1, is that when exceptions are thrown, that needs to be documented. Why would it be thrown? What kind of exception? So that's another one of these little style rules that you want to pay attention to. So, and you're practicing that in homework 1. Okay, I got a list of various things I want us to go over. Let's head back over here. Somebody asked in the Q&A, what happens if you want a different capacity? I mean, this one is setting up with a capacity of 100. It's a default kind of capacity. What if you wanted a capacity of 200? What if you wanted a capacity of 500? The way it's set up right now, it doesn't have the ability to make a bigger array than 100, which is not very useful. So it's nice if the constructor had an extra parameter for capacity, and we use that instead of using the 100. So I'm going to make that change, and so I'll just come over here and compile to make sure that it compiles. I'm not going to do anything with it. Oh, the bad index. Oh, good. All right. It reminds me that I never included the code here. There was a little pseudocode. What constitutes a bad index? Well, this is saying what constitutes a good index, that these two things are both true. In Chapter 5, there's a discussion of something called De Morgan's Law. So De Morgan's Law is a useful thing to kind of know. If this is a description of what makes a good index, a bad index is the negation of that. And the negation of something and something is the negation of this, and becomes or. Or if it was an or becomes an and. So what's the negation of index greater than or equal to 0? Index less than 0. There was an and, this becomes an or. What's the negation of index less than size? Index greater than or equal to size. So we negate the two things, we change the and to an or. Let me make sure it compiles. And I think this one is going to compile now. That'll be fine. Now, so it's nice to be able to have a capacity. By the way, that introduces, there's issues about what value capacity should have. What's the precondition? You could think about it a little bit. You'll see that I have code in there that I throw an exception if capacity is bad. What would be a bad capacity? You might want to think about it. You'll see it in the version that I'm going to post. Well, so this is nice to be able to do, but what if you wanted an array int list, list 3, which was a new array int list, and you kind of liked the old idea of, just give me one that's 100 long, give me the default, that'll be fine. So what if you wanted to do that? That's what we were doing before, but if I try compiling now, it gives me an error, and it says that it doesn't know how to do that kind of a constructor. Well, the rule in Java is that if you have any constructors, if you have no constructors, which is what we had kind of initially, the very first version we looked at for array int list, if you have no constructors at all, Java will make a zero argument constructor for you. That's what this is. We call that the zero argument constructor. So it would do that if you had no constructors, but if you have even one constructor, Java assumes that you know what you're doing, and that if you'd intended to have a public array int list zero argument constructor, you would have included it. If you meant to include it, if you wanted it, you would have included it. So when you have even one constructor, then you have to specify all of them, whatever ones you want. Well, I could put this back to element data is a new integer array 100 long, and I could say size is 0. So I could do that. That'll work. That's kind of doing my default thing. I would normally ask the class, but is there any issue with that? And people say redundancy. Why do I have these same lines of code here that I have here? Redundancy is a bad thing. We don't want to do that in general, so we wouldn't want to tend to write that code. Java gives you another option, which is that you can use the special keyword this. Remember, that refers to the implicit parameter, the object that you are talking to. And we were saying this dot in some of the other code that we wrote. Here we use parentheses, this with a paren. If you are writing a constructor and the very first line of the constructor is the keyword this with something in parens, then it's understood to be one constructor calling another constructor. So this is understood to be a call on this constructor over here. And it knows it's a call on this one because it sees an int. So it calls the constructor that takes an int. So this is kind of the better way of writing it. There's really only one constructor. This is the one that has the actual code that gets executed, and this one is calling the other one. That's described in Chapter 8, if that went a little bit fast. This isn't going to be relevant early in the course. I will remind you of this issue. It is a style issue that we expect you to use the this notation to eliminate redundancy, but it's not going to come up for a little while. And I'll remind you before we get there that that's a style issue that you need to be thinking about. Let me come back over here and make sure everything compiles, which it does, which is good. All right, I got a few more things I want to talk about relative to this little program. We had our index of method. Well, there's another method that's a little bit like it called contains, where you give it a value and it tells you, is this thing in the structure? In a way, if you had index of, you don't need contains. Contains is giving you less information. It's telling you true or false, whereas index of tells you where it is. So index of is better. But this is a common method, and the built-in array list has it. A lot of structures in Java have it. What's the return type? What kind of value are we returning? It's a Boolean. It's a true or a false. But we can write the contains method in terms of index of. What would be an index of that would tell us that it's in there? Well, remember, it returns an index if it finds it, and otherwise it returns a -1. So there's different ways of writing that. You can say if index of is greater than or equal to 0, then that meant that it's a real index. Or you could say it's not equal to -1. If those things are true, then and if that evaluates to true, we would return a true, and else we would return a false. So we can write the contains method in that way, and it would work. It would do what it's supposed to do. Let me make sure it compiles, just to make sure I didn't do a little syntax error. But this violates a different style rule that we're going to hold you to in 143. It was mentioned in 142, but we don't grade on it in 142, something known as Boolean Zen. That's described in Chapter 5. And there's a little section in the style guide, the online style guide. So Boolean Zen, this is something to know about. We grade on it even starting with homework 1. So the idea is that this is overly verbose. That if you really have internalized Boolean, it's become part of your being, you understand Boolean, you're not a novice anymore when it comes to Boolean, you would have not have written it in this way. Think about it. What's going on inside this little set of parentheses here? The if says, evaluate this expression. Calls index of, with the value it sees whether it's greater than or equal to 0. What does that evaluate to? It evaluates to either true or to false. It evaluates to a Boolean value. And you're saying if it evaluates to true, return true. If it evaluates to false, return false. But in either case, you're returning what it evaluates to. So why don't you just say that? Return what it evaluates to. Return the result of doing this test. Index of value greater than or equal to 0. In fact, you don't even need the parens. That was in there because it was an if-else, but you don't even need those. You can just kind of say return index of value greater than or equal to 0. That's the way to do it that has appropriate Boolean Zen. And again, that's something we grade on starting with homework 1. So add that to your list of things to make sure you understand. Go to TA office hours, ask your TA in section, if that's not clear. I want to show you one more method, and then we're going to look at kind of this final version. I want to have a public void method called addAll that takes an array int list other, and the idea would be that if you've got, say, 2 lists like this, you might ask list 1 to add all the values that are in list 2, which would mean that these 2 values, the 7 and the -8, would get appended to the end of list 1. That's what an addAll command is. It's asking you to add the things from the other list to the end of this list. And we can use our appending add to do that. So we'd want to go through the other list for int I equals 0, I less than other dot size, I plus plus. What we'd want to do is add to our list the other list's element data of I. So we'd want to kind of add all of the things that are at element data of I from the other list. So this is a way of doing it, assuming that we could ask for other.size without parentheses, and that we could ask for other.element data with the bracketed I. But remember, size and element data are private. So this isn't going to work, right? I mean, when I go to hit compile, it's not going to work. It did compile. So this is an important thing to understand. When you have one structure manipulating another structure of the same class, private has a different meaning in Java. Private means private to the class. All ArrayIntList objects have access to the private fields and private methods of other ArrayIntList objects. Now, I could have written this as other.get of I, and there's good arguments for doing that. And I could have put size paren here. So it would have been perfectly fine to have done it that way, but I wanted to show you that it works either way so that you're kind of aware of that. There's a second client program that I'm going to post for today that calls a lot of these different methods, the contains method, the get method. There's some code for addAll. I just wrote some sample code that does various kinds of manipulations. So you can download that if you want and download the new version of ArrayIntList and run it and see what it does. It's basically just a bunch of manipulations that kind of show various operations from this ArrayIntList. All right, I got a little over 2 minutes, and as I said, it's going to cut us off right at the end. So let me show you this final version. So this is the version you should be looking at to study, to kind of see something that's a good version. I introduced a constant for that capacity, the default capacity of 100. The constant, you'll notice, is declared public. It isn't dangerous to give people access to a constant because it's a constant. It's got this final keyword that would prevent a client from screwing up the value of this capacity. So we tend to make constants public even though the fields are private. So you'll notice that all of the different preconditions are documented here. I didn't mention this. Let me just kind of say quickly that here, that when you're constructing the exception, there's the option of adding a string to the exception. We don't require you to, so you don't have to do this if you don't want to, but it can be helpful for a client to kind of, so in this case, if they give you an illegal capacity, why don't you let them know what the illegal capacity was? So that's kind of a useful change to it. So there's lots of comments in all of this. One of the things that happened in here is that I found myself writing certain code over and over again. So for example, when I was doing remove, there was a check of an index. And I wrote that code multiple times. If you have redundant code, you can put it into a method. But we don't want you to introduce extra public methods that we didn't ask you to introduce. That's a style error if you introduced extra public methods. So you'll notice that at the end here, I have some private methods. So this is a method that checks the index. You can introduce as many private methods as you want to get rid of redundancy, or to give your code better structure. The final thing I'll mention is that this thing includes checks to make sure that we don't exceed the capacity. So if you did an add command or an add all command that was going to exceed the capacity, it throws an exception. So that's an extra bit of functionality. We're going to see a different strategy for dealing with what happens when you run out of capacity. We'll talk about that next week. And I think I'm about to run out of lecture time, so I'm going to leave it